All right, homework. Oh. 3, 2, 5.3.
Don, one of your lungs was going to come out.
I think one did. 5.3. 13 through 31. See how many we can get through. So when we look at 13, we look at PA is 2.9. PA is 2.9. HC is 10.8. HC is 10.8. When we're doing these bisectors from the vertexes, right? What we're doing is we're finding what's called the centroid. And with the centroid, it's really quite simple. We take 3 pieces, right? We take these 3 pieces right here. See that? And we're going to cut them into one big piece, one little piece. 2/3? Yeah, 2/3. So you have 2 pieces, you have 1 piece. This is 2/3. This is 1/3. Right? So this is 1/3, and that is 2/3, right? So if I know how big this piece is, right here, right? Then that means that I also know that this piece is 2 of those pieces, right? So that means that this blue piece right here is going to be 2 2.9s, which would be 5.8, right? In the same aspect, if I know that this is 10.8, I can split it up into 3 pieces, right? 3 goes into 10 how many times? 3, 1 left over, and it goes into 18 6 times, right? So it's 3.6. And if this is 2 of those, then that would be 6 plus 1.2, so that would be 7.2, right? And then what about this long piece? Do I know anything about it? No. So I can't find that piece. Hopefully they don't ask us. What's PC? Well, where's C? PC. Well, we found that to be 3.6. JA. Did we find JA yet? Yeah. JA goes from here all the way to there. Well, if they said this is 2.9, and this is 2 of those 2.9s, we said it was 5.8. Well, how much is the whole piece? And nothing but the piece. So help the piece. Get it? It'd be 2.9 plus 5.8, which is very good.
Yeah.
0.7, 6.7 plus 2, so what was that, 9.7? What's HP? Well, we found that to be 7.2. What's JP? JP patches. We got nothing on me. 5.8. We found that first. Ta-da! That's so easy. Do you get it?
Are you talking to me?
Yeah?
Yeah.
Okay. Do you get it, Nathan? Should I go over it again one more time?
No.
You sure?
I say we just keep
Isn't that your pen thing over there?
Huh? Yeah, probably. Is it gonna work? Come on, guys. Are you sure?
Yeah.
Everybody has trouble with these these centroids. I don't know why, but they do. All right. Here's the orthocenter of a triangle. So they're saying we're going to take this triangle, go -2, -2. Then they're saying go 6, 10. Okay. And then they're saying go 6, -6. So you have this triangle like this, right? The orthocenter, well, one nice thing about the orthocenter, right, is that you just need the midpoints, right? So we want to find this midpoint. Well, that went from 10 to -6, so it's halfway, 8, right? So 8 down from here would be 2, would that be right? So you want this line, right? And then, oh, I should probably videotaping this. Okay? So we're looking at this line right here, from this point to this point. Okay. Okay. So this is going to be 1, 2, 3, 4, 5, 6, and 2. This is going to be 6 and 10. This is going to be, what do we say? 6 and -6. And this was going to be -2, -2. And then to find the orthocenter, I just need to find the other midpoint. So could I find the midpoint between this one and this one, or this one and this one? It doesn't really matter. So remember, the midpoint says -2, -2, 6, and -6, right? I'm just going to add those up and divide by 2. Right? So I'm going to add those and divide by 2. So I have 4/2, which is 2, and I have -8/2, which is -4. So that would be 2, -4. 1, 2, and then 1, 2, 3, 4. Right? And that's coming from this direction. Okay? So that's 2, -4. Right? So now I got to find the intersection. Where do they intersect? And it looks like they intersect at 3, 1. That would be the orthocenter, or the center of the centroid. Yay, team! Right? 1, 2, 3, and then up 1. And I could always double check that by the slope between this and this. What is the slope of 6, 10, and 2 and -4? Well, that slope would be 10/6 negative 4 over 2, smack it. So that would be 14 over 4. That's nasty. That's not as nice as I thought it was going to be. Means it's up 14 over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 1, 2, 3, 4. That makes sense. And then this, if we plug that into the formula, plus b, x, and y equals, and then plugged in probably 2 and negative 4, right? Then we would have negative 4 equals 7 plus b. So minus 7 would be minus 11 equals b, right? So you have y is equal to m. Well, m was 14 over 4, wasn't it? 4, well, which is 7 over 2, x, minus 11. So that's one line. And then the other line, the red line, well, that's negative 2 over negative 2, and then 2 over 6, smack, smack. So that slope's going to be minus 4 over minus 8, which is equal to 1/2, positive. So it's up 1 over 2, right? So that means that you'd have y is equal to 1/2 x plus b. And so if I plugged in a y and an x, let's just plug in 6 and 2, and that would be 3. So 2 is equal to 3 plus b, minus 3 would be minus 1 equals b. So then you'd have y is equal to 1/2 x minus 1, right? And then you want to see where these things cross. So then you would say, well, then 7 over 2x minus 11 will equal to 1/2 x minus 1. Multiply everything by 2, so you get 7x minus 11 equals x minus 2. Subtract the x. 6x minus 11 equals minus 2. And then add 11. 6x equals 9. So then divide by 6, and you get x is equal to 9/6, which is really 1 1/2. For x. And then you'd plug that back into one of these equations, right? And get y. And I like this equation because it's smaller numbers. So 1/2 times 3/2, right? Minus 1 is equal to y. So then that's 3 over 4 minus 1 is equal to y. So what's 3/4 minus 1? Quarter. Bam. So that's actually where that point would be. That orthocenter wouldn't be where we thought it was 3 and 1. It would actually be at 1 1/2 Yay team.
You lost me back at like
I should probably do that again.
the negative 2.